Is this a pointer? Yes, this is it. Where do we have to get that thing going here? Yeah, so, well, first of all, thanks for the invitation and that you're sacrificing your lunch hour to listen to a topic about bibliometrics, which some people would find quite boring. We find it quite interesting. I'll try and make sure that we also have a setup at Crest where we have the split screen, and then the other day half of my class was sitting on this side and the other half there, and the class on the right-hand side says, I was just walking and looking at them the whole time and ignoring the other people. And I said, you the guys who ask questions, so the silent people, I'm not going to attend to them, but I'll try and split my, this kind of both ways, so to cover both areas. So the title is about rules, applications, and caveats about bibliometrics. And it really is in three parts. So I'll start with some introductory comments about bibliometrics. I had to assume that the audience knows what bibliometrics is. I can't really go into detail to define it. Of course, it's basically the quantitative study of texts. And people in library and information science are the best place to know this because one could argue that the bibliometrics grew out of early library and information science. And then I'm going to refer to some applications, and I have to apologize that these examples that I've used in the previous presentation here on campus last year, I haven't had time to update that. Someone said to me, if I get to that part and you've heard that part, you can doze off and then I'll wake you up for the third part. Unless you slept through the previous presentation, then you might want to be awake for this version of it. And then some final conclusions. And it will easily, I think, fit into the lunch hour. So I'm also happy if you want to interrupt and ask questions. So the more participatory it is, the better. We can have general discussion at the end, but if I say something that you want to immediately ask about, by all means. We have to understand that bibliometrics is a tool. I mean, bibliometrics is a form of measurement. Some people say applied mathematics, applied statistics. And like any tool, it can be used for different purposes, and it is used in different contexts. Now, let me just distinguish between two big areas of use. It has descriptive uses. So bibliometricians and bibliometric studies have been done to map scientific fields. So you want to look at a field like physics or sociology or whatever, and you can use bibliometric tools to map those fields, who work in those fields, who are the highly cited authors, which are the highly cited papers in those fields. So kind of epistemological mapping of fields. It can be used to study collaborations between scientists, institutions, countries, look at how collaborations change over time, and who you collaborate with and how that link up with other factors. There are methodologies and algorithms to identify emerging fields and so-called hot topics in science early on in the history of a discipline. And if you have the relevant data, and that is something that I'll come back to, of course you can also look at patterns and trends over time in terms of the demographics of science. And by that I mean the biographies of the scientist or author. So you can look at trends and patterns in the production of female scientists versus male scientists, or young scientists versus old scientists, and so on. And in something that is probably more relevant to people in information science, a lot of bibliometrics is used to look at patterns of publication behavior, who publishes where, in which journals, and also then to identify trends in citation behavior. So there are many more, but one part of bibliometrics is simply descriptive, just to describe the state of something at a certain point in time or over time. But arguably, because of various interesting developments and some not so interesting developments, the application of bibliometrics these days are much more in the field of evaluative bibliometrics, where bibliometrics is used as a tool to evaluate something, to assess something. Now, the background to that is that, and we can have a long discussion about, but since around the late 1980s and early 1990s, public science has increasingly been asked to account for public funding. Governments states invest in science, huge amounts in R&D. And since the 1990s and the advent of new public management, scientists and scientific institutions, including universities, have been called upon to account, to report on what they do with that money. And part of the way to do that is to show we publish certain things, we get cited, etc., etc. So we have new accountability regimes, and we see that in South Africa, funding agencies like the Department of Education and the NRF, they all require reporting on what you do with their money. And part of those reporting, bibliometrics start to come in. The internationalization of science, the fact that science has become global science, and the competitiveness, the competition for human capital and for the top scientists, that has led to the use of bibliometrics for that. And then constraints on resource allocation. If the NRF or the NIH or NSF have to decide which projects to fund, they can't fund every proposal, they start to use bibliometric indicators in the process of decision making. So this is the field of evaluative bibliometrics. That's not simply descriptive. Now you use bibliometric tools and indicators to assess the value, the potential impact, the potential uptake of something, a project, a program, an institution, a field. And this is where bibliometric indicators such as citation impact scores are usually used for evaluation purposes. The h-index, the famous h-index, because that essentially is assessing the quality, well, maybe not quality, but at least visibility, recognition, productivity of an individual scientist. And of course, journal impact factors, I don't have to tell you about journal impact factors, but the journal impact factor can be used purely descriptive, but in most cases it's not. It's used to rank journals. It's used to tell you something about the properties of the journal. And in all of this, we are now seeing that bibliometric indicators are really part of the assessment of research performance at every level. Now that is the big problem, that's a big challenge, because to assess the quality, visibility, impact, collaborative potential of science at the national level is a very different ballgame to assess the quality, etc., of research being done at Stellenbosch University or within the Department of Physics or, the work of a particular individual. And this is just different levels of analysis, and the rules that apply at these different levels have to be understood, because we're still using a tool, a measurement tool, which requires certain conditions to be met at each of these levels. So evaluative bibliometrics, and of course everything that has come in the last 10, 15 years, the whole rankings game, the fact that we have people like Elsevier and Thomson Reuters who have become huge data producers more than ever before. We have so many commercial companies who are now in the bibliometric game. And that means they develop new products which they want to sell, and these products generate more work and more indicators. So we have, you could even say we now have a bibliometric industry in the world, which is a huge industry driven from publishing houses, from governments, from various institutions. So it is not then surprising that bibliometrics is increasingly used, and in South Africa, and I've been following this now for the last 20, 25 years, it is just amazing to me. Every time we get a lot of requests from people, it has now become very, very much more intensive, sometimes a bit frantic and hectic, and sometimes completely irresponsible, the use of bibliometrics. But now deans of faculties assess individual research performance and say, okay, Professor X has an H-index of this and Professor Y not, so we give Professor X the promotion, you see. That's now using a one index as an evaluative tool. Or research managers evaluate university performance and assess the strengths of institutes. We sit at CREST at the moment with 2 or 3 requests to assess the performance of a specific institute and various requests to do comparison. The NRF is increasingly using it, but it's not just the NRF. In the UK, the research assessment exercise used it. Normally, the more responsible use is to use bibliometric measures like citation impact scores and h-indices in addition to peer review, because peer review through expert panels is a more qualitative measure. And so responsible research performance uses quantitative and qualitative measures. But I can tell you, when you sit on those panels, and you have someone here with an H-index of 35 or 40 or 45, and you have a qualitative report, people fixate on the numbers. Whatever the narrative report says, yeah, the guy has got an H-index of 40, you can't ignore that. And then I say, well, it's not a normalized, field normalized H-index score, so it doesn't really mean much. And then you have a whole debate about the relative value of these measures. And the rankings, I mean, this is the Shanghai rankings, the QS rankings, the Leiden multi-rank. I have stopped counting the times that I get calls from, DVCs for research and says, oh, I see my university is in ranking position 300, why can't, or outside of the 500, how can we get into the 500, The other day on a plane, someone from UWC says to me, he's got a center of excellence in the field of development studies, but they're not in the top 100 of the QS rankings for world subjects and development studies. How do we get in the top 100, Johann? That's it. I said, go away. This is a stupid question. So, but now for me, the interesting thing is, what do library and information scientists want to use bibliometrics for? I'm just going to leave that question, because I don't know. I can guess, but you have to decide how much, because part of the conversation that we've started now between Quest and the library and here at Stellenbosch is a closer working relationship. We are very keen to help where we can. But, is the aim of the people in this sector, in this section, to do evaluative bibliometrics, to do descriptive? Is it for collection management? Is it for what? Is it to support the research staff at the faculties? You see, they're very different things. So I'm putting this question up, and maybe we can talk about that a little bit later in the general discussion. But I can't answer that question on my own. You have to tell me why, besides issues of curiosity and other obvious reasons, why would you want to invest more time and effort in learning more about bibliometrics and to use bibliometrics hopefully more responsibly or to have greater impact? So keep in mind that that's a key question. Now, these slides I'm going to skip just to in detail, because I just want to show you, if we talk about the suite of bibliometric indicators that are available, we're talking about 40, 50, 60 types of indicators. And this is one classification. So you can use indicators to measure research output. And then you count number of papers, article equivalents, the outcomes of most productive people per journal, full paper count versus article fractional count. You can normalize it by weighting it. So, and you can do it at the university level, campus level, faculty, college department. So those 6, 7 core indicators suddenly become 20, 30 subsidiary indicators. You can study the shape of research production, basically by looking at indicators of where people publish, in which journals, and which journal indexes. For instance, a huge impact immediately, I mean, since the announcement, which is now official, that as of 2016, by the way, that's what I heard, from 2016, Scopus and Cielo and the Norwegian Research Council list are part of the DHET accredited list for subsidy. And I spoke to Chief Mabizela last week at the pub. I said, when does it come into effect? To say they're going to send out a letter to universities. It comes into effect next year for the 2015 submission. So we should tell our academics now this year already, when you consider publication, look also at Scopus journals and the Cielo journals or whatever, because you can get earned subsidy. And we know that there's a big difference in the journal list between, well, not a big, there's a fairly big difference between Scopus and Web of Science. But now, for us at Crest, it immediately changes the whole way in which we worked. Because up to now, in the last 15 years, 10 years, we've worked at doing bibliometric studies of South African publications only in the Web of Science, IBSS, and the South African local journals. We now have to incorporate bibliometric analysis of Scopus and the others. Cielo is not making a big difference, and the Norwegian list is not making a big difference. And of course, now the request from the Department of Higher Education is also look at the bibliometric properties of books. But book subsidies doubles next year from 5 to 10 per book. Now what's going to happen is people in the humanities and the social sciences who were wondering, should I rather invest in writing 10 articles the next 2-3 years, or rather put the book together? because the book only got 5 subsidy units and then it was proportional to size. Now, 10 units, you know, is R1,000,000, nah? Because the unit value is about 110,000 Rand. So if you publish a monograph where you're the single author and at least 300 pages, the university will get R1,000,000 in subsidy for that book, if it meets their criteria of a reputable publisher and whatever. And the other, let me just say, the huge other implication, which I don't know whether you've seen that, is that up to now, if I were to write a chapter in a book, and that book consists of 30 authors, I would get a proportion of the number of authors and page length. I would get 1/30th of the subsidy for the book, which was then 500,000. So I would get practically nothing. As of 2016, in the new funding formula, a chapter in a book is the equivalent of an article, irrespective of the length, irrespective of the number of authors in the book. So now, again, those people who said, do I go for article or I'm invited to write a chapter? A lot of people said, no, I don't want to write a chapter in the book because the subsidy value of that is much less than writing a separate article. They'll think twice now. So you can see, what I'm actually also trying to show to you is that for us working bibliometric studies, we don't work in a vacuum. We work within a policy context. We now have to re-gear, redirect our bibliometric stuff because we are going to work with new databases. Conference proceedings are going to become more important. Book citations are going to become more important. And so the whole, it is very possible that in the next 2, 3, 4 years we can see a subtle shift which may actually, in the way where people publish, and the people who probably are going to be benefiting more are the social science humanities, ironically. Because there's another thing. I'm sitting on the ASF Council last Wednesday when we have ASF Council meeting. There was a huge request. Sorry, I'm digressing because my slides are not so interesting, so I'm just talking. But so there was a huge request. The physicists in this country have sent a request to the Council of ASF. It says, we are being systematically penalized by the subsidy system because we work on multi-authored papers. Now, you know, in high energy physics, with the CERN project in France and Switzerland, you typically get a paper published by 200-300 authors. Then you've got one South African author there. Well, from a subsidy point of view, you get 1/300th of it. That's not even worth it. Some universities don't even submit those things for subsidy. But they say what this effectively means is that the current subsidy formula discourages international collaboration. So they now want an investigation by ASAF. How can we promote collaboration within the current policy framework? So you see, that's interesting how the policy decisions, the funding decisions, impact very, very specifically on performance measurement, because from a performance point of view, if I get a paper published and there are 300 other papers, I still count it as one full paper for my promotion. I'm not going to count it as 1/300th, you know. So it depends again what is the performance appraisal frameworks, whether they do full counting or fractional counting. There are many other bibliometric indicators. We do at CREST a lot of research demographics. Productivity is a big topic. I'll just show you about that. Research collaboration, I spoke about how we measure research collaboration. And then, of course, all the citation impact measures. And that's a field which is constantly evolving, where most bibliometric centers have field normalized citation impact scores, and increasingly looking at the top 10% highly cited papers is another measure. So I want to give you a sense that the field of bibliometrics and bibliometric indicators is a fast evolving field. If you get involved in this, it's exciting, but you have to realize that it's a big field of scholarship. It is not just a set of practices. There's a huge amount of work going on across the world in this. All right, let me go to my second part, and this is the part which I did last year, the research in Daba, so I'll go through this quite quickly. From the work that we've done, I've developed 6 rules, which I call 6 rules of evaluative bibliometrics, for what it's worth. The first is, this is very common. Remember, bibliometrics is a form of measurement, and measurement happens under certain conditions, and it has to conform with certain criteria and principles. So any measurement, and this now applies whether you're social sciences, natural sciences, whatever, is only as good as the underlying data. No argument there. If you've got rubbish data, you can stand on your head. Any amount of modeling statistics cannot save your data. That's the old garbage in, garbage out rule. Applies to bibliometrics as well. Now, what it means is that You have to be very clear. If you do bibliometric analysis, your underlying data sources, what are they? Are they the Web of Science data? Is it Subinet data? Is it IBSS data? Is it Scopus data? We have been working now we're the only center on the continent that has the raw data from Thomson Reuters, the Web of Science data. We have the actual microdata. We sometimes check against the online version that we count correctly, but we have something like 65 million records since 1980, the whole world science database. We have discovered mistakes in the Web of Science that we tell Rob Thomson Reuters about. We find some citations that are not linked to the underlying articles. We find that university affiliations in South Africa are incorrectly abbreviated in Thomson Reuters. The University of Witwatersrand, sometimes they confuse it with the University of Wittenberg in Germany. I mean, because what do they care about South African institutional names? There's no standardized thesaurus of South African names. We discovered Stellenbosch University has got 25 different spellings in the Web of Science. So if you don't take that into account, and you don't search for all those aliases, then you can do a lot of rubbish with your bibliometrics. And so the underlying data is crucial, and it's an ongoing job to clean the data. The second is a simple rule of any form of measurement where you work with small samples. Sample error is more prevalent where the sample of objects being measured is very small. Now, this is why I referred to this earlier. It's one thing to study the 5,000 papers of a university in a study. It's another thing to study the 50 papers of an individual scientist. The moment that you get to the individual level, the sample is one. There's one person. That's why people have problems with the h-index. It's still a measure of one person, you see. So then the sampling area is huge. So in evaluative bibliometrics, that's why we always say you never, at the level of the individual scientist, only use one indicator of anything, of research. You have to get a lot of other information and sometimes a lot of qualitative data as well. That's just simple sampling, principles. So this is the second rule, is the rule of sampling error, which applies to bibliometrics as well. The third one is that we must understand that science, bibliometrics is about measuring scientific communication and scientific publication. Now, not everything that we do in science and scientific research is equally measurable and certainly not equally quantifiable. The most elusive one is the idea of quality. What is quality in science? As we sit here, we do not have a generally accepted bibliometric measure of quality. Citation impact is not a measure of quality. It's a measure of visibility, of recognition. There is an interesting line of thinking, there's an interesting line of research at the moment developing at the level of the journal, not the individual scientist. Because the journal impact factor, of course, you all know how that has come under, what's the best word? Threat, critique, skepticism, the DORA declaration, all of that. We still use the journal impact factor because it's been refined and it's useful for certain purposes when you want to rank journals in the same field. But if you don't normalize the journal impact factor across fields, you get rubbish data. But there are now a very interesting line of thinking where people have started to look at the correlation between rejection rates of journals and journal impact factors. And so those journals like Nature and Lancet and so on, which have huge rejection rates, some people are claiming that's the best measure of quality of the journal because their peer review process that underpins the decision to reject or accept a paper is a qualitative measure. You use other peers in principle, peer scientists, to make a judgment. Is this article good enough? Is it a high quality article? And there's some correlation, not a strong one, but there's some correlation between the journal impact factor and the rejection rates. Of course, there's a nice cartoon. I saw that I was last year in Leiden, and someone gave a talk about this, and he says, of course, if you have a journal that rejects everything, then it's the highest quality journal in the world, but it won't publish anything. So then someone actually, I don't say it's probably one of his predatory journals or one of his pseudo journals, because then someone started a journal of universal rejection. We guarantee that you submit the journal article to us, we will reject it. You will have the highest rejection rate. We will never publish it, but you will have the satisfaction that you've submitted something to the Journal of Universal Rejection. Well, that's of course a bit of a joke. But the point that I want to make here is that in bibliometrics, certain concepts like collaboration cannot be captured in a single indicator. We use co-authorship as the best proxy of collaboration. But when I collaborate with scientists in my field, co-authorship is one way of capturing it. But we talk to each other, we collaborate in raising funds, you know, we plan projects together, we write funding proposals together. Collaboration is much broader than just writing the paper at the end as two co-authors. But we don't have measures of those other things easily. So what we then to do is that we reduce the construct, the underlying concept of collaboration, to what we can measure about it. And this is the rule of partial indicators. This is a concept that was introduced in 1980 by Ben Mouton from SPRU, where he says most indicators in science, never mind bibliometrics, are partial indicators. They only capture part of the meaning of the thing, the phenomenon that you want to measure. This is related to this one, and that is that there are many concepts in science which are intangible. Research quality is one. I've referred to research collaboration. And basically, our measures to measure that is a proxy measure of the construct. And what happens is that most of what people, then you find a second thing happening, that not only do we realize, people don't realize that co-authorship only partially measures collaboration, the construct or phenomenon of it, they then reduce collaboration to that and say this is, you know, the best way or the only way to measure collaboration is through co-author or multiple authorship. And that reductionist tendency we have to avoid. The fifth one, some of you will know that in the field of psychometrics and other forms of measurement, social measurement, there's the rule of the ecological fallacy. The rule of the ecological fallacy is, I'll give you an example from everyday life in social science. I go into a household and I establish that the household income for that is 10,000 Rand per month, for instance. At that level, I'm measuring the household. I cannot then infer from that that's the average income of that for every individual in the household. Let's say there's 5 people in the household, that everyone gets 2,000 Rand. You see, that's the ecological fallacy. Where you measure something at a higher level, you cannot, at a lower level, infer that the same properties apply there. It might be that one person in the household earns 9,000 and the other 4 people 1,000 between them. But that's why the ecological fallacy in social science means that when you measure something at a higher level, you have to be careful to make conclusions at a lower level. Now, that is exactly what happened with the journal impact factor. Exactly. So people say, I published in the journal impact, in the journal of an impact factor of 15.5. And by implication, so my article is also great. You know, my article is fantastic. My article is better than your article because you are published in a journal of an impact factor of 5. That's nonsense, you see. In fact, bibliometrically, there's about 0 correlation between the average citations to an article and the journal impact factor. Because the journal impact factor, you must remember, is an average, is an aggregate. It says that in a certain year, people published these articles. In the next 2 years, the citations to the articles in that journal were counted and averaged out. But it is literally possible, not impossible, that 100 articles were published in this year, and that 10 of them got 100 citations and the other 90 got 0. And therefore, the journal impact factor now averages out, and now you get the average for the journal. The journal impact factor lies at the level of the journal. You cannot conclude anything, really anything, unless you look at the distribution of the individual citations about the individual citation profiles of the individual articles. So people then say, well, why did we even bother with the journal impact factor? And it comes back because we think that the journal impact factor is more related to quality things about peer review and rejection rates. The fact that the journal with the highest impact factor is Cell, a journal in microbiology, 71, 72. Now what it says, of course, it says that every article on average gets 70 citations within a 2-year framework. And at that level, if you have large numbers, then the likelihood increases that the small other articles generate some citations. But the highest impact factor, I'm not sure that I show you the slide, in sociology is the annual review of sociology with an impact factor of 4. So this is now where field differences come in. You cannot compare the impact factor of journals in microbiology, where the top one is 70, with those in sociology. Why? Because sociologists and microbiologists do not cite in the same way. The citation behavior is different. The publication behavior is different. And so the field differences are the big thing. And that actually brings me to the last one. And that is that, in my view, this is the most important rule of evaluative bibliometrics. And I see that rule being violated every day, where people do comparisons of research performance output across fields. They compare what sociologists do with biologists, with health scientists, or whatever. They should stay away from it. We don't ever do that. I would never publish a report where I compare journal impact factors, citation impact factors, unless they're normalized. And to normalize them, you have to have access to the microdata, by the way. And so the rules of apples and pears is that you do not, and let me just say, there's another way of where this kicks in. A number of people have, over the years, they said, okay, so we believe you that you can't compare. So within the same university, the people in engineering faculty, when you do bibliometrics for them, it's a very different business than doing bibliometrics for humanities. That's one of the consequences of this. The other one is that we have to be even careful. So if someone says, well then, let's compare all the medical schools in the country, because now we're staying within the medical health science, all the engineering faculties. Well, there's a slight problem there. And this is, you go and look at the engineering faculties in this country, and you see what departments are included in the faculties. Different universities do not define engineering in the same way. At some universities, fields like town and regional planning, architecture is part, like at Pretoria, it's engineering and built environment. They have disciplines that sit in other faculties elsewhere. Yeah, electrical, civil, you will find in most. But even there, it's not straightforward because the organizational structure of university does not coincide with the scientific field structure in science. I mean, I just did a study for UWC. At UWC, I saw, what the heck, political studies sits in the Faculty of Economic and Management Sciences. It does, it's political studies. They have a Faculty of Humanities, which has sociology and psychology. But I spoke to someone in political science, said, why? He said, well, we don't know. We were told to be part of management, we're part of the School of Government. But in most other universities, the Department of Political Studies would be in the School of Social Sciences or Humanities, not linked to Economic and Management Sciences. So this is why we have to be very careful when you start to make comparisons across universities, across fields. Stay away from it. Stay within the same field. Yes, I can compare the output of physicists in this country or sociologists, but then you have to be careful, of course, for smaller samples. All right, so a few applications, and then I'll move on. Again, I've updated a few slides here, but those people who are at the Research and Daba here will recognize some of this. I'll say a few things about topics which I think people are very keen on. The one is university rankings, so let's talk about rankings. I don't actually want to talk about rankings, but let's talk about rankings. So let me show you what is the problem with rankings, one of the problems with rankings. So here are two claims. So the DVC for research at UCT, Dani Visser says, UCT is the top ranked university in the country. And then Eugene Klutek gets on the same platform and says, nah, Dani, Stellenbosch is the top ranked university in the country. And of course both are right, because they use two different ranking systems. So how does this work now? Let me give you have you go back. So what you see there, what Dani Visser is saying, South Africa is the top ranked university on the Shanghai ranking, which is factually true. Stellenbosch is number 3 on that, of the South African universities. What you're looking at here are the 2014 rank results for the 4 South African universities that made it into the Shanghai, the ARWU rankings. But now, any ranking of anything makes no sense unless you tell me what are the measures that I'm being ranked on. If my wife says you're a fantastic husband, of course I'll believe it. If she means because you give me always money for shopping, then that doesn't really count. If she says you're being flowers, that does count, you see. A ranking means nothing without telling me what I'm being ranked on or rated on. So now, the Shanghai ranking has 6 indicators. 4 of them are bibliometric. Here are the 4 bibliometric ones. Publications were in the Web of Science. So your absolute number of publications of a university in the Web of Science for a certain time frame gives you 20% of your ranking. The absolute number. Doesn't matter how big you are. If you're Harvard that has 5,000 staff, or UWC that's got 800 staff, you still just count the number of publications. So how can that be fair? There is no normalization for size on that indicator. The second one is, how many papers have you published in 2 journals, Nature and Science? Well, what about the poor people, the humanities, social science, economic management science, law, theology? They don't publish in law. So now you rule out those universities that are strong in humanities don't have a chance to get as a mark, a point on that second. That counts for 20%. We're now up to 40%. The third one is a bit more of a normalized, it looks at the number of proportion that you have in the highly cited papers per field. And citation can be normalized. So 60%, the first 3 publications, and then we get an interesting thing. The last one is per capita publications. That is the only one of the 6 indicators in the Shanghai ranking that normalizes for the size of the institution. What they do there, they take those publications in that column, the third column there, and they divide it by the academic staff of the university where they can find that information internationally. And that counts for 10%. Why they would not bring that into the first 2, I don't know. But anyway, so now 70%. Where does the other 30% come from? 20% if you have a current Nobel alumnus or alumni, and 10% if you have so current Nobel Prize winner, and 10% if you had Nobel alumni. Now there's a slight problem. So a Nobel Prize winner in physics studies at Harvard, does his research at Harvard, goes to Princeton, works there for 10 years, and now gets counted twice. Because at the point of the ranking, he's at the Princeton, so he's a current Nobel, he got a Nobel Prize in the meantime. But he's an alumni from Harvard. So Harvard claimed him for 10%, and Princeton claims him for 20%, the same person. That's why Sidney Brenner at UCT is still being claimed by UCT as a historic alumni. The only 2 or 3 universities in Africa that have Nobel alumni are Wits, UKZ, and UCT, each one of them won. They still count a little bit there. That's why they are in there. So you see, if you look at it objectively, if someone had to design a ranking system, do you think that they could have come up with this? Well, they came up with this in China, so that's what you have to remember. And why, by the way? You have to ask yourself, why did the Chinese investigate? Because the Chinese government says China must become competitive with Germany and UK and America and Canada in terms of publications. We want a ranking system that shows us how we compare with them. They developed that system as completely from political motives, not anything related strictly to bibliometrics. And that's why the Shanghai ranking is not taken seriously by bibliometricians. It's taken seriously by those DVCs of the top 500 countries. Yes, of course they are. Now, so, all right, so UCT, Wits, Stellenbosch, UKZ, we're there, and that's good. Now, I come back to Eugene Klutter's claim and says, well, hang on, that's a Shanghai ranking. There's a much better ranking. That's the Department of Higher Education and Training ranking. So why is it a better ranking? Because it takes into account the realities of South Africa. The Department of Higher Education and Training in this country have since 2005 ranked. It's not made very public, but there's a ranking table. Every year there's a report that comes out from the department. If you want to see it, I can send it to you. They send it out, they never publish it. And every university is ranked on 6 indicators. The number of subsidized journal articles in the Web of Science, South African journals, and IBSs. The number of conference proceedings, books, book chapters, 4 indicators, the number of master's graduates, and the number of PhD graduates, which get a weight of 3. If you then add up all of this, you get the weighted per capita research output. So what happens is that for Stellenbosch University, for every university, they would add up, literally, they add up all the public articles. We produce about 1,300 articles a year, and then some chapters and books. And they add up all the publication units. We produce about 700-800 masters a year. And in 2013, we produced the highest number of PhD graduates in the country, 240. They multiply that by 3, because PhD graduates get 3 times. And they added all of that up, and that came to approximately 2,700 units, and they divided by the academic headcount. The HIMSS tables every year publishes the number of instructional staff. At Stellenbosch, that sits about at 900. At UCT it sits at 1100. At Pretoria it sits at 1400. So, although in absolute terms, if you look at the number of publications, the university that now constantly publishes in the largest number of publication units as UKZN or Pretoria, but both of them are about 40-50% larger than Stellenbosch. And UCT is number of staff, and UCT is about 15%. We produce about the same as UCT. They produce a bit more publications. We produce, even in absolute terms, we produced in 2013 more PhDs than Pretoria. Last year, I think it's slightly less. But that's why, if you look at this, that's the last column, is the average weighted per capita research output. It's a measure. It's not just a bibliometric measure, it's a measure of human capital. And for the last 4 years, since 2010, Stellenbosch has consistently occupied the first position on this ranking, using these 6 indicators. So yes, Eugene is correct. Stellenbosch is the top-ranked university in South Africa. But you see now comes QS, and then other universities come in, and then Leiden, you multi-ranker. So Stellenbosch is the top one on this ranking. UCT is the top South African on another one. But there is no overlap, really, in the indicators between these 2 rankings. And of course, as people say, what about other indicators? The amount of research income. What about teaching and learning? The ratio of students, all of that. What about community engagement? Why are we not measuring these 6? We only measure the things that we can measure. That's a reductionist point. So can you understand why I'm not very excited about rankings? I mean, to my mind, the question you have to ask yourself is what purpose do they serve? Besides the obvious one that a DVC can stand up at council or a VC can stand at press and say, we're the best on this ranking. It makes the university look good. They think that attracts more students. Already the top universities in this country get more students than they can accommodate anyway. So what is the point about doing that? The students are also smart. They know what are the top universities anyway, by word of mouth. Do you think they wait for the day that the rankings come out to take a decision? No. So this is all a reputational, this is symbolic posturing. And for me, as bibliometrician, I don't find that particularly interesting. Anyway, so, all right, so that's the thing about rankings. I do want to explain something about the rankings, and then I must skip a few slides so that we have time, and I'll just get to my final slides. There is an interesting question to be asked about the rankings, and that is, why is UCT on the Shanghai ranking the highest South African university, and why is Stellenbosch, which looks so good on the one ranking where you use other indicators, why has it not been in the top 200 like UCT? That is an interesting question. Besides, because we know why in the sense of because they use different indicators. But the more interesting thing for me is that I wanted to understand at a deeper level what is it about science production at UCT that gets them into that position on those indicators. And Stellenbosch, if we measure them on the same indicators, we get them position number 3 or 4. Well, the most important reason comes back to those first 2 or 3 indicators, because in the Shanghai ranking, the web of science, the number of papers, nature and science, the citations, the web of science is the journal list that is being used. So what I'm going to show you now is that you have to look at the shape of knowledge production. Marie has now heard this so many times, but what can I say? It's still true. We do this analysis at CREST where we disaggregate, and I should update this to SA Web of Science, not ISI. But if you look at these 4 indexes, there's the foreign, what we call the foreign Web of Science. These are all the journals in the Web of Science which excludes the South African. There are about 67, 70 South African journals in the Web of Science. They are the SA Web of Science. Then you have the local South African journals. There are about 230 local South African journals that do not appear in the Web of Science. A lot into law, theology, humanities, and so on, but also health science. And then there's IBSS, which is such an unimportant factor. So UCT, if you look at 2011, and you add the yellow and the blue bars, because that's Web of Science, 90% of all the papers produced at UCT appears in the Web of Science. So from a Shanghai point of view, the ranking picks them up because they count articles in the Web of Science. Well, remember that, 90% of UCT papers in the Web of Science. This is Pretoria. Now, Pretoria, sorry, the colors are not compatible. So here you have to look at the red and the green. The Web of Science red is foreign Web of Science, and green is Web of Science South Africa. Essentially, in 2010, about the same time, half of Pretoria's output appeared in the Web of Science, the green and red part. The other half, the blue part, those are the local South African journals. So even though Pretoria produces in absolute numbers more papers per year than UCT, not in the Web of Science they don't. 50% of their 1,400 papers, that's 700. 90% of the 1,300, you can make the sums, you see. So UP does not have a presence in the Web of Science on the indicator that counts the most. And sorry to say, let me go to the worst case scenario out of the top 12, UNISA. So here's UNISA. Now you have to look, the foreign journals in the Web of Science is red, and the South African in the Web of Science is blue. So the red and blue, that's not even 20%. 80% of UNISA's output is in local journals and some IBS journals. So UNISA has no hope ever to get on Shanghai. They can stand on their head, they can bribe the people, whatever. They're not going to get there because it doesn't matter that they produce 900 papers per year. 20% of them in the Web of Science. They will never, the first three categories in the Shanghai, they don't even register on the radar screen. And then for me the interesting thing comes, now how come is that? And this is now my favorite story these days, is that what is the big difference between the University of Pretoria and UCT in terms of the shape of knowledge production? University of Pretoria, if you remember that big blue part, that blue part is essentially people in the humanities. Pretoria has a huge faculty of theology. In fact, they merged two faculties. They have a big faculty of law and a decent faculty, let me put a decent faculty, Marie, for human sciences. So, and those people publish in local journals because remember, there are 25 theology journals, 25 law journals are created in this country. There are 50 journals out of 250, 1/5 are in the fields of law and theology. The people, all the historically Afrikaans universities, Pretoria, Northwest Potch, Free State, Stellenbosch to some extent, not exactly comparable. They set up big faculties of theology, of law. They set up big schools of education, nursing and social work. Why? To train the dominees, the doctors, the nurses, the social workers for the folk. That was, no, I'm not kidding this. You go and look at the mission statements. They were to study. In the 1930s, Professor Stoker at Potch said, we must train the professionals for the Afrikaner nation. So the university has become a professional training ground. Now, where are the professionals? They are the dominees, the lawyers, the priests, whatever. So UCT, they've never been for any folk. So, because remember, UCT is an English liberal university. The training is about liberal arts. They don't have a faculty of theology. They don't have a school of law. They have a small department of law. Their school of education doesn't train teachers. So what do they have? A huge medical school, huge natural sciences. Where do they publish? Web of Science. So this is for me a fascinating picture because it took us a few years to sort it out. We're a bit slow there at Quest. But the point is that, you know, you have to understand these rankings are related to where people publish and where they get rewarded to publish. And then you have to say, well, hang on, why do you have so many in local journals? And that relates to the history of the missions of the institutions. The fact that University of Pretoria, Northwest, and Stellenbosch, and Wits and UCT have different histories are essential to understanding the bibliometric properties of their publications. And of course, universities don't change overnight. In 10 years' time, there will still be a faculty of theology at Pretoria. It's still a faculty of law. So how do you shift it? How do you get them in the Shanghai rankings? Well, why do you even bother? You see my point. There are many more interesting questions about bibliometrics than worrying about getting into the rankings. But I thought I had to say this, tell you the story, because people have become obsessed with rankings. So the other parts of this, in the interest of time, I'm going to skip a little bit because we run out of time, and I want to get to my 5 final slides. You will see in the slides, because you have it, and Marie and Marlene can circulate it to you. Comparison across scientific fields, there's a whole thing about that. We are in discussion with the MRC. The MRC has a research performance framework which makes no sense. They have a situation where in the health sciences, if someone publishes a paper, this is literally their rules. This comes from, the MRC has the most, and of course remember the MRC, the Medical Research Council, affects every university that has an MRC unit. And Stellenbosch has many MRC units, like UCT. So at the MRC, if you're a director of a unit for MSc and your staff publishes in high-impact journals, they have a rule. They say you get 0.5 points for every journal the unit publishes in with an impact factor of bigger than 3 but smaller than 5, and you get a 4 point for every article in a journal with an impact factor larger than 5. I said to Paul van Helden the other day, because he's a good friend of mine, I said, Paul, who the hell, sorry for the recording here, who the dickens decided on these things? Well, he told me, but I won't tell you. I said, because anyone who knows anything about bibliometrics of health sciences will tell you there's a serious flaw here. The health sciences is not a homogeneous set of fields. There's a huge difference between people publishing in nursing and occupational therapy, in surgery, in infectious diseases, in anatomy. There's a big difference between the clinical disciplines and the biomedical, the laboratory disciplines. So people, if you were to, you could do a simple test as a library. You all have access to the Web of Science and Scopus. Go and look at the journal impact factors in the different health sciences fields. And you'll say, yeah, Lancet, New Journal of English Medicine, those are the big things. But if you go down to subfields like anatomy, surgery, pathology, virology, whatever, the range of the impact factors are different. So it is perfectly possible that I publish in the field of nursing where getting a journal impact factor of 4 is the highest impact factor for a journal, and I should get a full point. And someone else publishes in the field of infectious diseases, impact factor 4, but the highest journal has got 30, you see? So there's no normalization of the differences of journal impact factors within health sciences according to this framework. So anyway, they've now got the message, and they've asked us to help them revise the framework, which will be an interesting challenge. So, but this affects people's monies, because on the basis of these scores, units got funding from the MRC. This is why evaluative bibliometrics have become a high-stakes game, and people get promoted on the scores on this framework. And if this framework is inherently flawed, you are penalizing people and their careers and, whatever. So these are not small matters. It really have large consequences. So anyway, I will skip these other slides. I've done too many slides as usual. So let me just come to the stuff about full paper versus fractional counting. I compare research productivity by faculty in the same fields. You can look at that. The lawyers and the theologians always publish the most. So, and this whole thing about collaboration and citation impact. So finally, just to conclude, research performance strategies and bibliometrics within that are context bound. So this means that whenever you work in the field of bibliometrics, working in South Africa is different than working in Europe, where the EU have other concerns. And we have to work within a policy and goal context which affects what are acceptable or not. In a South African context, you cannot do evaluative bibliometrics without knowing exactly the funding framework of the Department of Education and how it influences everything that happens at university. And the recently revised framework, as I said earlier, is going to have huge consequences, which we are starting to understand now. Research performance strategies using bibliometrics must be differentiated. This is my story about the differences between fields and disciplines, different purposes of research assessment. You cannot set the same set of targets and rules for people in different disciplines and different universities and different faculties. And differences arise are embedded in the differences in methodology and epistemology of scientific fields. There's a huge difference to use bibliometrics to help decide about resource allocation, who gets funding. It is very different to use bibliometrics to incentivize and reward performance, like everyone in this country except for UCT. The money that they get from the department flows to the individual author. Some universities like DUT, out of the 110,000, the author gets 70,000. TUT, 60,000. The average is about 30,000. Stellenbosch way behind, 14,000 I think we get now. And then in some cases you can take it as salary. So at TUT or DUT, people tell me, why do I publish? I publish 4 papers a year in the easiest journals that I can publish, because those 4 journal articles are going to get me 4 times 70,000 rand in my pocket. I pay tax on it, but who cares? We all pay tax. Seriously, people are now publishing for income. But the worst case scenario, not for quality, not for recognition, publishing to augment their salaries. We've created a bit of a monster in the Department of Higher Education funding system. And it can be used for other purposes as well. So My last concluding slide is aimed at or specifically at library information science, because we've had huge debates in this country, and I recognize that Elsevier is represented here. Over the last 4 or 5 years, we've seen this huge development towards off-the-shelf bibliometric analytics, Insights, SciVal, all of these. And I've been a critic of that, not because I'm critical of the people who produce it, but the way that it's been used. And you have to realize that these products, they're based on underlying fairly clean data, but they are off-the-shelf products that can only, to a limited extent, be customized. And the problem is that they have a restricted value, as far as I'm concerned, and I've been public about this, and I've said it to Elsevier and Thomson Reuters, which we collaborate with and hope to collaborate in other ways. They are expensive in the long run. It's an interesting thing. I spoke to people at UNISA recently. They had signed a 3-year contract with either Thomson Reuters or Elsevier, which they're now stopping. Because, you know, the interesting thing is if you use SciVal and Insights once, you get a picture of the university, if it's a decent picture. You can't keep on generating the same stuff. I mean, then it becomes old news. And by the way, if you do that analysis in 2013, do you think the science landscape at Stellenbosch would look very different in 2014 and 2015? So now the point is you're locked into a 3-year contract. In some cases, they lock you into other data products, which I think is slightly unethical, but it makes good commercial sense to them. So my point is that at the long run, it's a fairly expensive option. The second is they're constrained by predefined queries. As people get more interested and more expert in bibliometrics, they ask more and more detailed, specific questions that the off-the-shelf products cannot answer. So someone in this faculty wants to know in this discipline a set of questions which are not covered by the product. Then you have to go back and get people to run queries for you on the microdata. And they do not take into account the peculiarities of the institutional research landscape. But by that I mean, I told the people at UNISA, why did you even buy the Web of Science, Insights, the product? Because only 20% of your research is published in the Web of Science. So every analysis that you did using Insights was on 20% of your scientific production. It ignored the other 80%. What kind of decision is that, you see? So, yeah, it might make sense for UCT, for WITS to some extent, Stellenbosch to some extent. We estimate Stellenbosch at about 75–80% in the Web of Science. So that's my final thing, is that we have to be very well informed about what these products can do, what they can bring to us, and what value they add and what value they don't add. Can't remember that was, so I'll leave it. Thank you very much.
Thank you, Professor, for your time and your knowledge that you shared.